All right, today we're going to discuss in this video the operation of the John Bean BFH1000. This machine is located here in the Snap-on shop. The interesting thing about this machine is it uses three-dimensional imaging by using three different lasers. So you can see in the illustration there the lasers coming at it in three different directions coming at the tire assembly. Those lasers are located here, here, and then there's another one back here behind the machine that we can't see, but it's located in a box that tracks out on a bar here. So those lasers come into operation when we lower the hood and the machine does its automatic balancing. Okay, so here we have the display screen and the control panel. On the display screen, you'll see these small little boxes across the bottom. These are called icons, and these icons are numbered F1 through F6. They correspond with F1 through F6 buttons on the control panel. The four buttons along the bottom here are an escape button, ESC, a help button, a start button, and a stop button. Generally, the machine is set up so that when you close the hood, it automatically starts, and so you won't often need the start button. The stop button would be used in an emergency. To get back to the home screen where you'll want to begin, just hit escape, and then you'll see the image of a vehicle, the John Bean logo, and this function screen. Okay, here we have a tray that's organized in a way that we can keep our various weights. We have clip-on weights and adhesive weights in here. We also have a series of adapters that will match up to the wheel to mount the wheel onto the spindle, which you can see over here. One of the features of this machine is it uses what's called a power clamp. It's a very fast device to mount the wheel up onto the spindle and then put the power clamp in, slide it on, and then by pulling up on this foot pedal here, then you can see the little clips come out, and those would pull the power clamp into place. And then just simply pull up again, and the little hooks go out, and that would release this power clamp. So we'll demonstrate that again when we mount a wheel up onto the spindle. This foot pedal is also used as a brake, but we don't use it to slow down or stop the wheel. We use it when we apply the weights to the wheel. So after the machine has done its calculations and determined how much weight to put on the wheel and the location of the weight, then we can rotate the wheel around, hold the wheel into place with this brake while we attach the weights. We'll demo that again too as we go through the balance demonstration. Before we mount the wheel onto the balancer, there's a few things we need to do to get it prepared correctly. Very first thing is we want to check the air pressure and make sure that we have the factory recommended amount of pressure in the tire before we mount it onto the machine. The other thing we want to do is if it has a center cap assembly like we have here, we're going to want to remove that. Generally, you can just pop those out from the back. And the next thing we want to do is remove any weights that might be existing on the wheel. So spin the wheel around, look for any clip-on weights that might be in place. If there are any tape-on weights, you'll want to remove those. Also, any debris, any excessive amounts of rust or mud should also be removed. For example, I usually take a wire brush and clean off this center hub a little bit just to remove any rust. This is where it's going to meet the flange on the spindle assembly, and we don't want to introduce any run out that doesn't need to be there. In addition to removing any clip-on weights or adhesive weights or rust or debris, also be sure to go around and check the treads and remove any large rocks from the tread. All right, we've selected the proper adapter that fits in the center hole towards the rear of the wheel. We're going to slide it onto the spindle. Then we'll lift the wheel up onto the spindle. And I try to be careful here, not bang up against the spindle so much. I just want to keep the machine calibrated. Then we're going to use the power clamp. Slide the power clamp on. No fingers in between here because it's going to suck that power clamp on with a lot of force. Then, using the foot pedal, you're going to pull up, and it's going to pull the wheel right up against the drive flange on the spindle. All right, so we're going to close the hood now. The machine will automatically spin up. If you can see the image on the screen, you can see the laser, or lasers in this case, are moving around the wheel, dimensioning. Right now it's counting the spokes, checking dimensions. Then it spins the wheel up, and automatically now you can see that we need 1/4 ounce weight on the inside plane of the wheel and 1/2 ounce of weight on the outside plane of the wheel. All right, let's take a little bit closer look at this screen. There's some icons here I should point out. We already mentioned the weight dimensions here are given for the inside and outside plane. Notice these small little icons up here. This machine, if we were set up for it, has a variety of color-coded wheel weights, and the machine has already calculated what color of weight we should choose and what type of weight we should choose. So you can see these 2 yellow weights here. The machine is defaulted to using clip-on weights on the outside and inside plane. The flanges on the wheel are different on each side, and so on the inside flange we use the blue weight, and you'll notice it looks a little bit different. The clip shape is a little bit different to grab on snugly around the flange of the wheel. And then the outside clip is got a little bit different shape still to grab on to the outside. Now, because this is an alloy wheel, and often people prefer not to have visible weights around the outside flange of the wheel, generally we will use adhesive weights. And this machine has the feature to change the weights around so that you can tell it which weight combination you prefer, and it will recalculate automatically then the difference in amount of weight that you should use. So if you look down here at this F2 button, this is a toggle button actually, and if I just touch the bottom edge of it, then you can see the weight has changed. So that outside weight now has moved, and we have a yellow highlight here that shows an adhesive weight being used on the inside of the wheel, so it wouldn't be visible to the customer or from the outside of the wheel. And we're still using the clip-on weight on the inside. I can toggle it again, and we can see where we would position 2 adhesive weights, and again the calculation is made because we've changed the position of the weight, then the amount of weight changes slightly as well. Toggle again. Now we're using an adhesive weight on the inside plane and an adhesive weight on the outside of the outside plane. So we're outside where it would in fact be visible, but it'd be kind of hard to see because if it's an adhesive weight, it's going to be up in the inside edge of the wheel. Another icon that you see here is this little green check mark. The machine's been set up to look at the tire tread, and if the tire tread is less than the standard 2/32 of an inch, then it'll give you a little exclamation mark there that the tire tread is really getting too low, the tire's getting too worn out and should be replaced. Okay, so we're going to select a clip-on weight for the inside plane, which the machine's going to tell us we need 1/2 ounce there. And then we've also selected to have an adhesive or stick-on weight for the outside plane. Now we're going to put that outside plane weight on the inside of the companion flange so that it's not visible from the outside of the wheel. And that we need to put 0.75 or 3/4 ounce there. Okay, I forgot to point out earlier that we have a molded plastic piece here that looks like the shape of a pointer, and that's exactly what it is. It's a pointer. Whenever we use clip-on weights, we're going to rotate the wheel up until the machine gives us the green graphic, push the pedal down to brake the wheel, and then you can clip your clip-on weight right in line with that plastic pointer. Okay, so we've installed the clip-on weight on the inside plane of the wheel. Now I'm going to rotate the wheel by hand and get the green arrows on the outside plane. We'll begin to line up here. There we go. Now I'm going to step on the brake pedal to lock the wheel in that position so it won't move on me while I attach the adhesive weight on the inside of the wheel or the outer plane. Whenever we choose adhesive weights or stick-on weights, then the machine uses one of the lasers to locate the exact position where the weight should go. So this is where I'm going to center that weight right where the laser is telling me to put it. Before I attach the weight, however, you always want to clean thoroughly any rust and debris off. The cleaner you get it, the better the weight will stick on to the inside of the wheel. In a commercial setting, they wouldn't use a hand wire wheel, they'd probably use a whizzy wheel. So get the corrosion cleaned off, then remove the adhesive backing, place the weight right into position, stick it down, and you're ready to recheck your measurement. So we'll lower the hood. The machine will check our balance. And we should come up zeros on both planes. This tire's ready to roll. One of the advantages of the laser device, the 3D imaging on this machine, is it eliminates the need for the technician to have to do any input to the machine on the dimensions of the wheel. As you know, on manual balancers, you have to tell the machine what the width of the bead is, the width of the wheel. You need to put in the diameter of the wheel. And when you mount the wheel up onto the spindle, you have to dimension the distance of the inside bead and input a number off of the scale here. So it eliminates the need of using the calipers or measuring the distance between the spindle flange and the inside bead, as well as any input on the wheel diameter. Remember that the purpose of this video is to give you an overview of the basic operation of the machine used for your review or preview. Just be sure that you've had an instructor-led demonstration and been checked off by your instructor to use the machine.